Hello, good evening. My name is Viji and I'm from Kaizen Academy. So I'm here to teach you physics, some concepts on physics. So this is the 12th standard physics syllabus which we are right now doing here. So you can see that, see the topic name on the board, Coulomb's law in electrostatics. A very, very important law when you talk about electrostatics. But before we go to it, let's see what it means. See, it means interaction of charges. So let's first think about charges. Okay, when you hear about charges, what comes to your mind is an atom, right? So let's imagine an atom. An atom has a positively charged center which we call as nucleus. Nucleus has protons and neutrons in it. And we have a cloud of electrons which is revolving around the positively charged nucleus. So this is what comes to our mind when we think about charges. So here what we can see is there is a negatively charged electron, and then we can see a positively charged proton and a neutral neutron. So what we actually see here is a neutral particle also. So that means that actually generalizes what you mean by charge. Charge is not something which should be there on a body. There's nothing like that a body should have charge. No. There can be charged bodies. There can be bodies without charge also. See, we have one here, neutron. So we have a neutron which is uncharged, or rather we will call it as neutral. That's the term we usually use. So neutrons are neutral. Then we have a negatively charged electron. Electron having a negative charge. Then we have a positively charged proton which actually gives the nucleus its positive charge. So we have a proton which is a positive charge. So now when we actually conclude, so we know that bodies can be charged, it need not be charged. So we can have neutral bodies and charged bodies. So when we look at the charged bodies, they come in two types of charges. You can see that some bodies have negative charge and some bodies have positive charges. So this is a classification what we usually do. But having said that, negative doesn't mean the value is less. So suppose I have two values to compare. Suppose I take minus 6 Coulomb and plus 3 Coulomb. If I ask you which charge is more, it is a tendency that seeing the negative charge, we say that 3 Coulomb is more. So this is where it leads to some sort of confusion when we use the positive and negative signs. But what we need to understand is, according to Benjamin Franklin, who named charges, who classified charges, these are just two types of charges. We have two types of charges. One type is positive and the other type is negative. That doesn't mean minus 6 means the value is less. No. Plus and minus just denotes that there are two different types of charges on the body. So this particular body has a charge positive and this particular body has a negative charge. That much only. But if we are looking at the magnitude, which charge is of more magnitude? 6. See, compared to the number 3, 6 is more. So we say that 6 Coulomb, or we say that minus 6 Coulomb has more magnitude of charge. But if we are looking at the signs, there is a tendency that we may go wrong. Always remember, negative and positive are just two types of charges on the body. So all in all, we can conclude that we have two types of charges, positive and negative. So a body can take either positive charge or a body can take a negative charge. Now, what do you mean by this getting charged? Getting charged means the body has to lose or gain electrons. Let's discuss more on that. So when we actually think about it, let's look at the atom. Suppose an atom has p number of positive or p number of protons. Okay, it has p number of protons. It has e number of electrons. And all of us know that in an atom, the number of protons is equal to the number of electrons. So this P has to be equal to E. These are the only two charged bodies in an atom. So if there are 4 protons, there are 4 positive charges. If there are 4 electrons, there are 4 negative charges. So the positive and negative will cancel out. Cancels out mainly because the charge on a proton and the charge on an electron is equal. The charge on a proton is given by E, which is 1.602 into 10 raised to minus 19 coulomb. Electric charge का SI unit is coulomb. Now, when we look at the charge on an electron, it is just minus E. The value is same. It is only negatively charged. That's the only difference. See, the value is same. The value is again 1.602 into 10 raised to minus 19 coulomb. That means when you come to an atom, there are 4 negative charges, 4 positive charges which are equal. So when you take an atom as a whole, it is electrically neutral. Why? Because the number of positive charges cancels the number of negative charges. So see, P and E. So the number of positive charges is P, the number of negative charges is E. So they cancel out. So the atom has no charge in general. And that's why we say that an atom is electrically neutral. So now, when we actually think about the atom, so we are thinking like, then how can we have charged bodies if the atom is neutral? If all the atoms are electrically neutral, how can we have charged bodies? Yes, we can have charged bodies mainly because an atom can lose or gain electrons. There are 3 methods by which the atom can lose or gain electrons. The first method is charging by friction. Friction is a contact force. We all know that 2 bodies have to be in contact for a frictional force, for producing a frictional force. So we just rub our hands. What happens is, some of the electrons will jump from one hand to the other hand. So they got charged. Understood? So problem here is 2 bodies. So suppose I take a glass rod and a silk cloth. So I am rubbing a glass rod on a silk cloth. Glass has more tendency to lose electrons to silk. So suppose glass lost 5 electrons. Glass lost 5 electrons to silk. So the glass rod which I am talking about lost 5 electrons. Lost 5 electrons to silk. So what is the charge gained by the glass rod? Think. The charge gained by the glass rod will be positive or negative. It lost 5 electrons. Electrons matlab negative charges. It lost negative charges, then glass rod becomes positively charged. Silk gained these 5 electrons. So silk got more negative charges. So silk becomes more negative. So glass rod develops positive charges on it and silk cloth develops negative charges on it. So this is what we actually did in the last few sessions when we discussed about electric charges. We actually discussed all this in detail. Okay, so by rubbing just means you are producing some sort of friction by which one body loses electrons to the other body. You can actually feel it in many places. So we have already discussed this. This is just a revision of those concepts. So We already know that charging by friction is one method to make a body charged. So here I made glass rod charged, silk cloth also charged. Glass rod got positively charged and the silk cloth got negatively charged. We are talking about electrostatics, matlab these charges are going to stay on that surface. But unfortunately the amount of charge it gains is very less, that it will not stay for long. It will just get thrown into air. So it just gets lost very fast. Now the second method is charging by conduction. So we've already discussed the charging by friction. So the second method is charging by conduction. Now what exactly is charging by conduction? You have an uncharged body. Okay, you are bringing another body close to it. Let me call this as A and this as B. Suppose A has positive charges on it. B has no charges, but still the electrons in B will feel that attraction towards these positive charges and they will all rush towards the positive charges. So all the electrons now rushes towards the positive charges. So electrons goes and neutralizes those positive charges. May not neutralize all of them, but they will still try to neutralize the majority. So what happens? B has lost electrons. If B has lost electrons, what is the charge which B will get? Yes, B will be getting positively charged. And since charges repel, they will redistribute. See, there will be a certain gap between the charges because charges will definitely redistribute themselves on the surface of B. Okay, I repeat, you brought a positively charged rod near a conductor B. Okay, B was initially uncharged. So when you touched A, when you brought them into contact, A lost charges. How did A lose its positive charge? Electrons from B, free electrons from B came and neutralized those charges on A. So these charges got neutralized. It might not get neutralized fully, but certain amount of charges got neutralized. But what happened to B in that process? B actually lost electrons, losing negative charges. Matlab B got more positive. So B became more positive. So actually it was not at all charged. Now B has got charges on it. What type of charges? Positive charges. So you can actually say in general, suppose you bring a positively charged conductor or any charge for that matter in contact with B. B will also gain the same type of charge. If A is positive, B will also be positively charged. If A is negative, B will get negative charges. So this is what we can call as sharing. If they are identically charged bodies, they share equally. Like suppose you have two identical spheres connected by means of a wire. So I said identical spheres, so their radii are same, their size and all is same. Now suppose this has plus 6 microcoulomb charge and this has minus 3 microcoulomb charge. Now what happens when you connect them by means of a wire? A will lose charges to B. So the total charge now what we will be having is 6 minus 3, that is 3 microcoulomb. That will be equally distributed on A and B. So A will be getting 3 microcoulomb. B will also be getting 3 microcoulomb. Am I right? No. The total charges is 3 microcoulomb. Total. So that means it has to divide equally. See? So 3 will divide equally into 1.5 microcoulomb and 1.5 microcoulomb. This is the charge on A and B now. Remember, A can be still connected by means of a wire, but charges will not flow from one body to the another anymore. Charges will flow only if there is a potential difference. So if A is at a higher potential, charges will flow from A to B. If B is at a higher potential, charges will flow from B to A. So charges always flow only if there is a potential difference. So initially here A had more charges. So the charge flow was from A to B. It was flowing from A to B. Afterwards, they got same type of charges. Now if they have got same type of charges and the potential is same, then they won't exchange anymore. So they reached an equilibrium. So now there is no more exchange of charges. The charge on A is 1.5 microcoulomb and the charge on B is also 1.5 microcoulomb. So this is what we call as charging by conduction. So this example I have discussed for similar bodies, identical bodies. Identical bodies share equally. But if you have two bodies which are not identical, like the radius is different for the two spheres you have considered, then obviously it depends on the radius also. Okay children, so this is the second method of charging by conduction. Now the third method, charging by induction. In charging by induction, we don't bring the two bodies in contact. So, if you have a positively charged rod and you are bringing it closer to a body, closer to a sphere, the electrons will try accumulating here because this body is positively charged. So, the electrons will try accumulating here. So, electrons accumulate at this end. Since electrons are lost from this part of the surface, this end gets positively charged. Okay? And now what happens? Can the electrons jump and go to the positively charged rod? No. You have air in between. Air is an insulator. Only if the electric field is very high, air becomes a conductor. Else, air is an insulator. So if air is an insulator, then the electrons cannot jump and go there. Electron stays here. So all the electrons from every part comes and accumulates here. Similarly, since the electrons have gone, the other areas keep getting positively charged because the electrons are lost from that part. So when it loses electrons, it becomes positive. So positive charges are developed on the other side. Okay, so now what we do is a simple practice. Touch it. Touching, matlab you are providing earthing, all the charges will flow to the ground. Touch it, all these charges flows to the ground. Now the negative charges will distribute evenly when you remove the positively charged rod. So let me remove the positively charged rod. The negative charges will distribute evenly. See, then the repulsion comes into effect. So they will distribute evenly on the surface. Okay, so what do you understand from this? In case of charging by induction, the second body gets opposite charge, opposite type of charge. See, I brought a positively charged rod. That was my A. B got negatively charged. See, B got negatively charged. So, opposite type of charges are induced in the third method, which we call as charging by induction. So, here, remember there is no contact. No contact between the charged body and the uncharged body. So this is what you mean by charging by induction. So these are the three ways by which you make a body charged. So again, we got a body charged. So let us conclude, how did we get the body charged? Either the body has to lose electrons or the body has to gain electrons. However be the method, whether the method be 1, 2 or 3. The body has to either lose electrons or gain electrons. That is why the body gets charged. So, how did these charges come into effect? Just by exchange of electrons. A body gets charged by exchange of electrons. So there is a simple formula to write the charge on the body, which we have discussed in the previous lecture. The properties of charges are already discussed. So in that property we have mentioned that charges are quantized. So there's a simple formula we wrote for it. Q is equal to plus or minus Ne. Charge on one electron is E. Okay? Plus or minus will depend on whether the body has lost electron or gained electron. I repeat, if a body loses electron, it loses a negative charge. So it becomes positive. Loses electron, charge is positive. If the body gains electron, it is gaining a negative charge. So it becomes negatively charged. The charge on the body is negative. So that's how you decide whether the charge has to be plus or minus. So in general it is exchange of electrons. Okay, so how do we decide whether it is plus or minus? Will depend on this. Now we have discussed about plus or minus. We know the value of E. I have already written the value of E. 1.602 into 10 raised to minus 19 coulomb. That's the charge on one electron. Now, depending on the number of electrons lost, suppose it loses 2 electrons. This n here is an integer, which can be 1, 2, 3, etc. So, if a body loses 2 electrons, for example, if a body loses 2 electrons, what type of charge will it get? It has lost a negative charge. It becomes positive. So the charge has to be positive. Now what is the value? It has lost 2 electrons. So N is 2. So the charge on the body is plus 2E. This is how you decide what is the charge on a body. So we understood about charges. So charge is an inherent property of matter by virtue of which the body can have a charge or it need not have a charge. Okay, so a body can have charge or need not have a charge. The value, like how it gets charged, is all what we discussed now. Now when we have charges, definitely they will interact. You know that like charges repel and unlike charges attract. Now their interaction is what we are going to discuss by means of Coulomb's law. So what is the magnitude of that force? Suppose you bring two negatively charged bodies closer to each other. We know that they are both negatively charged bodies. They repel. So there is a force between them. What is the magnitude of that force? What is the direction of that force? That is what we are going to discuss here in Coulomb's law in electrostatics. Okay, so it is basically an interaction of charges. So that is all about Coulomb's law in electrostatics. Now, we actually compare it to a very simple law which you have studied in 11th standard, Newton's law of gravitation. Let us just compare and see Newton's law of gravitation. Newton's law of gravitation deals with masses. So the equation what we got is G m1 m2 by r square, where you have two masses m1 and m2 separated by a distance r between them. So this force is directly proportional to the amount of mass. Like if the masses are increasing, this force will also increase. Distance of separation. If the distance is less, the force will be more. So that is what we discussed about Newton's law of gravitation. And we know that that is also an inverse square law because the force is inversely proportional to r square, distance square. So it is not actually inversely proportional to r, it is inversely proportional to r square. Similarly, electrostatic force is also an inverse square law. Matlab, here electrostatic force will also be inversely proportional to r square. So you bring charges very close to each other, the force will be more, it will be strong. If you take them far apart, the force will be weak. So it actually depends on the square, inversely proportional to the square of the distance between them. Now, so it is a similar force, but what are the differences? Gravitational force is a long range force, electrostatic force is a short range force, acts only at short distances. And again, gravitational force, you know, is only attractive, but electrostatic force can be repulsive also. Like charges repel and unlike charges attract. So it can be attractive and repulsive. So that's all in this video. To know more about Coulomb's law in electrostatics, the actual equation, please watch my next video. Thank you. Children, I forgot to mention, in case you have not liked our videos, please go to our website, subscribe the channel, and please like our videos so that you can get the latest updates. Okay, so we were discussing about Coulomb's law in electrostatics. In that, I have already given you an introduction why we need this law. So we know about the force, we know about the existence of electric force between two charges. But what we don't know is how to measure the force. What will be the magnitude of the force? And how do you actually say that the force is strong, the force is weak and all. So the measuring part is what we are going to deal with now. So as all of you know, Coulomb's law in electrostatics is an inverse square law. We will also see that. And then we have already discussed that it is the interaction of charges. So interaction of charges means we can have either like charges or unlike charges. Like charges, both should have the same type of charge, either both positive or both negative. Then we can have unlike charges, one positive and one negative. So there are two options. You can have like charges or unlike charges. Like charges repel and unlike charges attract. So there is a repulsion, there is an attraction. So that is the most important thing of a electric force, because electric force can be attractive or repulsive. So let us see how to find the magnitude of this force. It is given by Coulomb's law. So according to the law, electric force is directly proportional to the product of the magnitudes of the two charges. So it is directly proportional to the product of the magnitude of the two charges Q1 and Q2. That means if you increase the magnitude of the charge, like from 1 coulomb I made it 4 coulomb. So obviously the force of repulsion or attraction also increases. Similarly, as you bring the charges more closer, you can see that the electric force becomes stronger. So electric force is more when you bring the charges closer. So this is what we need to see now. So F is directly proportional to Q1, Q2. It is inversely proportional to the square of the distance between the charges. So here comes inverse square law. Force is directly proportional, inversely proportional, inverse square law. Force is inversely proportional to the square of the distance between the charges. So it is not that like you bring two charges closer to each other, the distance decreases, so force increases, but it is not depending on r. Instead, it is depending on r square. So that is what we need to note here. So let us write the force equation together. So force is directly proportional to Q1, Q2 by r square. Or you can remove the proportionality and include a constant. F is equal to K Q1 Q2 by r square. This gives you the magnitude of the force. Like you can actually calculate the value of the force if you have the Q1 Q2 values and the r values. So distance, if you have the two charges, the magnitude of the two charges and the distance between them, we can find out the force acting between them. So a very simple equation to find out the force. I will talk about the constant after some time. So now I told you about the force. Now what we need to understand is how will this force act? So this force acts along the line joining the two charges. Okay? This force acts along the line joining the two charges. A very important point. This force acts along the line joining the charges. So what do you mean by acting along the line joining the charges? Let us see. Suppose I have two like charges. Positive, positive. Okay, so I am keeping two positive charges here. One here, one here. You know that like charges means they will definitely repel. So let us write down the force on each one. Okay, so I am going to write force on Q1 by Q2 first. Force on Q1 by Q2. Okay, I will name this force as F21. Force on Q1 by Q2. See, this is not a standard naming procedure. Force on Q1 by Q2 can be written as F21 or it can be written as F12 also. Okay, this naming will depend on how you want to consider it, but I will take it rather this way. Force on Q1 by Q2. This is little easy for you to understand if you take the naming like this. So, force on Q1 by Q2. So, who is the sufferer? Q1. So, what is the kind of force acting on Q1? Let's see. Q2, both being like charges, definitely they will repel. So, Q2 is going to repel Q1 along the same line. Q2 is going to repel Q1 along the same line. So you can imagine I have a positive charge seated at this place, okay, and another charge is coming closer or it is kept in front of me. Definitely both being the same type, I will repel that charge. It is not allowed to come closer. I'll repel that charge. So Q2 is repelling Q1 away. This is force on Q1 by Q2. Similarly, we can write the opposite also. Force on Q2 by Q1, which we will represent as F21. I will talk about this in detail in our next video. Right now, you just understand the naming procedure. So, force on Q2 by Q1. So, force is on Q2 by Q1 now. So, Q2 is repelled away. This is F21. So if you actually notice, both the forces are along the same line joining the two charges. See, these are the two charges and the line joining the two charges is R. It is separated by a distance R. So the F21 and F12 is along this line. You will be thinking because they are kept in a straight line, like horizontally. Let us see if I am keeping it somewhere. So I have Q1 here, Q2 here. This distance between them is R, usually taken as R. So now Q1 is repelling Q2 away. So how does Q1 repel Q2? Q1, both are positive. So Q1 will repel Q2, matlab push it away along the same line. This is F21, force on Q2 by Q1. Similarly, how will we represent F12? Force on Q1. Q1 will be repelled away by Q2. F12, force on Q1 by Q2. You can see that they are along the same line. This is what I meant here. Such forces are called as central forces. So electric force is a central force. Electric or electrostatic force, because we are dealing with static charges here. So electric force is a central force. Okay, so what do you mean by central force? A force which acts along the line joining the two charges. See, these are the two charges. The force which acts along the line joining the two charges are what we call as central forces. So hope you got the idea what exactly I meant by a central force here. This electric force is also a central force. See, it is acting along the line joining the charges. Okay, so now you have got an idea that this is how the forces act. So it will either push or pull the charges. Pulling will come in case of unlike charges. I told you, which I'll be explaining in detail in the next video. So I'm not going to talk more about it. Let's come back to the magnitude of force now. So we have two charges separated by a distance r. So I have given the equation for force as F is equal to K Q1 Q2 by R square. Now, let us write the value of K. It is seen that K depends on the system of units and the medium. The medium of interaction, the medium in between the two charges, the medium of interaction. Okay, so now system of units, we can have SI system or CGS system. In CGS system, the value of K is 1. In CGS system, K's value is 1. So let us only talk about SI then. In SI system, now I have to include the medium also. If the medium is air or in air medium, the value of K is given by 1 by 4 pi epsilon naught, which is equal to 9 into 10 raised to 9. 4 pi is a constant, you know. The only constant which you might not know about is epsilon naught. It is called as absolute permittivity or permittivity of the medium. Permittivity just means allow. So it is allowing the field lines to pass through. So permittivity is a term which we will be using in electrostatics. So wherever you have two charges, we will be talking about their interaction in terms of a constant. So if it is an air medium, the constant K is 1 by 4 pi epsilon naught, where epsilon naught is absolute permittivity or permittivity in air. Or you can call air and vacuum together as free space. We normally call it as free space. So I hope you got the value. Epsilon naught permittivity has a value 8.85 into 10 raised to minus 12. We'll be writing the unit a little later. Okay. 22 by 7. Epsilon naught, it has a name. It is called as absolute permittivity. Absolute permittivity. Absolute permittivity or permittivity of free space. Free space means air or vacuum. This is the value of K in air medium. Okay, and this constant epsilon naught is called as the absolute permittivity or permittivity of free space. Matlab, the word permit itself means to permit through it. Understood? So it again depends on the medium, no? How much it will permit the electric field lines to pass through. So how much will it permit? Again, that permittance will depend on the medium also. So that is why we have different constants for different mediums. Here, for air medium, the constant is epsilon naught, and it has a value which is equal to 8.85 into 10 raised to minus 12. This is the value of epsilon naught. So we have got the value of epsilon naught here. Q net I will write a little later. So as I told you, epsilon naught is called as absolute permittivity or permittivity of free space, because the value of K which I wrote is for air. Now for any other medium, in a medium, the value of K is 1 by 4 pi epsilon. I cannot write the value for this because epsilon will depend on the medium, whether it is water, air, depending on the different types of medium, the epsilon can take different values. So we cannot write a constant value for it. But what do we call it? Permittivity of the medium. We call it as permittivity of the medium. That's how we call epsilon. So now permittivity of the medium. So now we have got the two equations. In air and medium, we have got two equations. In air, you know the value of K is 1 by 4 pi epsilon naught. In any other medium, K is 1 by 4 pi epsilon. So depending on which, force will have two equations. In air, the value of force is 1 by 4 pi epsilon naught Q1 Q2 by R square. In medium, 1 by 4 pi epsilon Q1 Q2 by R square. So that's how you write the two equations for forces. So in air and medium, we have got two different equations. One thing we need to know, we define another quantity called as relative permittivity. What is relative permittivity? Relative permittivity is referred to as epsilon R. It is when you relate two quantities. See, you know what is relative density. Relative density is density of the substance with respect to density of water at 4 degrees Celsius. So water's value at 4 degrees Celsius we keep as a standard, and then we compare the value of the substance. Similarly, for all the different types of the medium, we have the relative permittivity values. So if you see your Clark's tables, you see all the constants written there, all the physical constants are given there. So you will see relative permittivity values for different mediums. So how do you write it? Relative permittivity is defined as the absolute permittivity is what we take as the standard. Okay. So absolute permittivity comes in the denominator and the permittivity of the medium will come in the numerator. So this is how we write relative permittivity. It is defined as the ratio of absolute permittivity to, ratio of permittivity of the medium to absolute permittivity. So absolute permittivity is the standard here. According to this equation, epsilon R will not have any unit. See, ratio of similar quantities. So relative permittivity has no unit in dimension because it is a ratio of two similar quantities. Then why did we write it? Let's see. So epsilon becomes equal to epsilon naught epsilon R. This is why we wrote it. Epsilon becomes equal to epsilon naught epsilon R. Let's substitute it here. So epsilon for us is epsilon naught epsilon R. So we have substituted that value here. 1 by 4 pi epsilon naught epsilon r. Now we have the value of 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught is 9 into 10 raised to 9. You can substitute. So the only unknown here will be the epsilon r, which will be mentioned in the question. The relative permittivity of a particular medium will be mentioned in the question. So you will be able to solve the problem by using the 1 by 4 pi epsilon naught value. So we have already discussed the equations. Now coming to the most important part. Which is stronger? Which force is stronger, in air or in medium? Can you make a guess by looking at the equations? See, I am talking about two similar charges separated by the same distance. In that case, Q1, Q2 by r square will get cancelled. Now, if you compare, if you take the ratio, 1 by 4 pi epsilon naught will get cancelled. So you get F air by Fm is 1 by epsilon r. What does it mean? F air is equal to epsilon r times Fm. Means the force in air is stronger. You bring two charges, two like charges in air medium. You keep them in air medium and then you take it to some other medium. You can see that like charges matlab they will be repelling. So the repulsion became weaker when you took to another medium. So in another medium compared to air, the value will be, the force value will be less. So from 40 it might have reduced to 30. So you can see that the repulsion became weak. Hope you got it. So earlier repulsion was very strong. So they separate by a large distance. Now when the repulsion becomes weak, they separate by a smaller distance. Okay, so they tend to come closer. Okay, there are some questions in NEET and all with respect to this, like whether the distance between them will be less or greater when you keep them in a medium. So this is what you need to understand. So when you take from air medium to some other medium, the force becomes weak. If it is attractive force, earlier the attraction was very strong. Now when you take it to medium, the attraction becomes weak. So they separate more. So this is how you have to understand how these forces work. So as a recap, I would want to tell you about the forces again. The two equations, the equation for force in air, 1 by 4 pi epsilon naught Q1 Q2 by r square. Force in medium, 1 by 4 pi epsilon naught epsilon r, where epsilon r is the relative permittivity, Q1 Q2 by r square. Now, another thing what you need to remember is force in air is stronger. It is epsilon r times Fm. So, depends on the medium. It again depends on the medium. Please note down the constant values. And now, another thing what you need to understand is the unit. I have not written the unit of epsilon naught. Let's complete that also. How do we write the unit? So, suppose I choose this equation. I want to write epsilon naught's unit. Bring epsilon naught here, force comes down. Okay? So, let us write the unit. I'll write the unit here. I hope everybody is noting this down. So, the SI unit of epsilon naught. How do you write it? See? So, epsilon naught comes this side, 1 by F. I am leaving the constants because when you are writing the unit, we don't have to actually write the constants. 1 by F, Q1, Q2 by R square. So, let's write the unit. Charge, Coulomb square. Charge into charge, Coulomb square. By force is Newton. Distance square, meter square. So, epsilon naught's unit you have already got. It is Coulomb square, Newton raised to -1, meter raised to -2. See, they both are in the denominators. So we can write down here Coulomb square, Newton raised to -1, meter raised to -2. Other than that, what you need to know is force. Force SI unit is Newton. So We have the SI unit of force Newton, SI unit of epsilon naught I have already written. Epsilon will also have same unit. SI unit of epsilon naught and epsilon. Epsilon R, I told you it is the ratio of similar quantities, so no unit in dimension. So again, coming to the main point, the thing which you should not forget is the force between two charges act along the centers, the line joining the centers of two charges. That is the most important point here. Okay, so that's all in Coulomb's law. Let's come to the statement. Statement also is based on this equation. The electric force of attraction or repulsion between two point charges at rest. Very important, children, the charges have to be at rest. We can apply Coulomb's law only if the charges are at rest. Very important. Okay, so and they have to be point charges. What do you mean by point charges? The charges whose size is negligible compared to the magnitude of the charge. So the magnitude of charge is more compared to the size. So they are actually, you can imagine them as points. Okay, so the force of attraction or repulsion between two point charges at rest is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Now you can actually include, suppose sometimes they will say define or state the law in air medium. Then you can also include that also in the equation. So the electric force of attraction or repulsion between two point charges in air at rest. So you can include those 2 points. At rest in air is directly proportional to the product of the magnitudes of the two charges and inversely proportional to the square of the distance between them. So that will give you the statement of Coulomb's law. So please know this statement also. This question is usually asked as state and explain Coulomb's law in electrostatics. And I have already told you why inverse square law. You can see that the force is inversely proportional to the square of the distance between the charges. So definitely it is an inverse square law, square relationship. So hence this law is called as inverse square law in electrostatics. So this is how basically charges interact. So you know in which direction the forces will act, and now you know how to write the equation and find the magnitude of the force involved, the electric force involved. And electric force can be attractive or repulsive based on the type of the charges. Okay, so that's regarding Coulomb's law. We'll discuss about Coulomb's law in vector form in our next video. Thank you.